Welcome to ROAV Perfect classes. In this video, I will discuss about computer system architecture, which is important for BSCIT, BCA, MCA, MTECH, BTECH, UGC NET, GATE exams, or any type of competitive exams which are related to computer science and computer applications. Now, first, I am going to discuss about what is memory hierarchy. Hierarchy means levels. Memory hierarchy is the hierarchy of memory and storage devices. Storage devices which are found in the computer system, and it ranges from slowest to highest. Highest capacity, secondary memory to fastest but lowest capacity cache memory. Why we need it? There are three types of features of memory: cost, capacity, access time. These are three features, these are three key characteristics of memory which are need to balance. So that's why we use memory hierarchy. Now, this is a memory hierarchy diagram. First of all, CPU registers, then cache memory, then main memory, then secondary memory, and then tertiary memory. First, that is known as level 0, cache memory level 1, main memory level 2, secondary memory level 3, and tertiary memory level 4. This is a memory hierarchy. Now, first is CPU register, that is known as level 0. At level 0, registers are present and which are included inside the CPU. Because they are present inside the CPU and they have least access. Time. Second, these CPU registers are most expensive. So these are smaller in size. you can say smallest in size, they will be in KB, and these registers are implemented by using flip-flops. By using flip-flops. You should be keep in mind that CPU registers have least access time. These are most expensive. So that's why these are meet us in smallest size in KB form, or these are implemented by using flip-flops. Now, second level is cache memory, that is known as level 1. Cache memory is also present in CPU. It stores the segments of program. It stores segment of program which are frequently accessed by a processor. Which are frequently accessed by a processor. And cache memory also expensive like CPU registers, but cache memory less expensive than CPU registers. So these are smaller in size but in MBs, not in KB, because CPU registers are more smaller than cache memory. So that's why these are given in KB, and cache memories are smaller than CPU registers. So that's why these are given in MB. And cache memory is implemented by using static RAM. Static RAM, that is also known as SRAM. Now next level is level 2, or you can say level 3 in number, that is main memory. At level 2, main memory is present. It can communicate. It can communicate directly. It can communicate directly with CPU. Directly with CPU and with secondary memory. And with secondary memory devices through the input-output processor. Through the input-output processor. And main memory is less expensive as compared to cache memory and CPU register. So these are larger in size as compared to cache memory and CPU registers. These are given in few GBs, gigabytes. And main memory is also implemented by using dynamic memory, dynamic RAM, random access memory, that is known as DRAM. Now next is a secondary memory. Secondary memory is present on the level 3, and in secondary memory we use magnetic disk. Magnetic disk. These are used for backup. These are used for backup storage. Backup storage. And these are also present in large in size, larger in size as compared to main memory, cache memory, CPU in few terabytes. At level 4, territory storage devices are present. These territory memory include magnetic tape. Magnetic tape. You should be keep in mind that in secondary memory we use magnetic disk for the backup storage, but in territory memory we use magnetic tape. And these magnetic tapes are removable files used to store removable files, and these are too much cheaper as compared to secondary, main memory, cache memory and CPU, cheaper, and that's why it is given in largest in size. All of these above memories largest in size, that is given in 1 to 20 terabytes or more. These are the memory hierarchy. Now next I am going to discuss about its observations. Observations can be made when going down in the memory hierarchy, means from CPU register to cache memory to main memory to secondary memory to territory memory. When we go from top to down, means from top to down, then its cost per bit decreases. Second, frequency of access also decreases, but capacity increases, and access time also increases. These are the observation of memory hierarchy. Now next point is, what are the main goals of why? What are the main goals of memory hierarchy? Main goals of memory hierarchy. The main goal of memory hierarchy is to get highest possible average access speed. Second main goal is minimize the cost of whole memory system. These two are the main goals of memory hierarchy. Now I am going to discuss next important topic, that is memory organization. Memory organization in computer architecture. Memory is organized at different levels, which are discussed in previous slides. And CPU may try to access different levels of memory in a different ways. On the basis of on the basis of these levels, memory is divided further in two parts. First is simultaneous, that means same way simultaneous access memory organization. And second type is hierarchical. Access memory organization. Means in simultaneously, we have given example. Just first, this is a CPU and it has divided in two memories. First is cache memory, second is main memory. This is a simultaneous access memory organization. But when we use hierarchical access memory organization, then CPU under cache memory, then main memory. This is a hierarchical access organization. In simultaneous access memory organization, all levels of memory are directly connected to CPU. All levels, cache memory, main memory, both are directly connected to CPU. Whenever CPU requires any word, it starts searching for it in all levels of cache memory and main memory at a simultaneously way. But in hierarchical access memory organization, when any word, if you want to find out any word, then CPU first goes to cache memory, then cache memory. If in cache memory you do not find that word, then cache memory goes for it to the main memory. So you can say in this case, main memory is not directly connected with the CPU. Main memory is connected with the cache memory and cache memory is connected with the CPU. This does not connect with the directly CPU. Who connected with the CPU? Only cache memory. Cache memory is connected with CPU and cache memory is connected with main memory. And cache memory's work is a mediator between the CPU and main memory. Now, I am going to discuss its practical problems related to memory organization. First question, that is related to memory organization, that is problem first. What is the average memory access time? Average memory access time for a machine with a cache hit rate of 70% and cache access time of 5 nanoseconds and main memory access time of 100 nanoseconds. When we have to find out hierarchical access memory organization is used. Second, simultaneous access memory organization is used. For this, first of all, you have to clear what things are given. We have given, according to first point, CPU and cache memory. You can see here cache and main memory. We have given two memories, cache memory and main memory. Or according to second point, you can draw it like this: cache memory and main memory. You can say that in this hit ratio is given of cache, that is 70%, that is given. That is given 70%. And or we have given cache access time, that is 5 nanoseconds. And in main memory we have given only access time, that is given nanoseconds, 100 nanoseconds. And main memory hit ratio we will take here 1. According to rule, last memory will be equal last memory's hit ratio will be equal to 1. So now I am going to solve it. First, we will use formula average memory access time, that is equal to hit ratio of one level multiply access time ratio or access time of first level plus 1 minus H1 multiply H2 multiply T1 plus T2. H1 is given 0.7 multiply T1 is given 5 nanoseconds and 1 minus 0.7 multiply H2 will be taken as 1 and T1 is given 5 nanosecond, T2 is given 100. 0.7 multiply 5 plus 0.3. 1 minus 0.7 that is equal to 0.3 multiply 1 multiply 5 plus 100 105. This is 35. 7 5 is the 35. That will be equal to 3.5 plus 105 multiply 0.3. 3 5 is the 15. 3 1 is the 3. 0 0 0. You will calculate it. That is 31.5. 31.5. When we add 3.5, we will get 35 is the answer of average memory access time. That is equal to 35 nanoseconds. Now, second case, that is related to simultaneous access memory organization. In this case, we will use formula average memory access time is equal to H1 multiply T1 plus 1 minus H1 multiply H2 multiply T2. H1 is given 0.7 multiply T1 5, 1 minus 0.7, 1 multiply 100. 3.5, when we multiply 0.7 with the 5, then we get 3.5 plus 0.3 multiply 1 multiply 100. 3.5 plus 30, that is equal to 3.5 plus 30, that is equal to 33.5 nanosecond. You can see when we use simultaneous access memory organization, then average memory access time will be 33.5, or when we use hierarchical method, then it will be 35 nanoseconds. This is the example of how to solve average memory access time in simultaneous access memory organization when we use hierarchical access memory organization. Now I am going to discuss next question, which is related to 3 levels, more than 2. That means which is related to 3 levels. Question is, we have given a computer has a cache main memory, cache memory, main memory and a disk. We have given 3 levels: cache memory, main memory and secondary memory. And access to the cache memory takes 20 nanoseconds. 20 nanoseconds. And access to main memory takes 100 nanoseconds and access to disk takes 10,000 nanoseconds. Suppose cache hit ratio is 0.8 and main memory hit ratio, that is 0.7. The effective access time required to access a referenced word on the system is dash when first is simultaneous access memory organization is used, second when hierarchy access memory organization used. Now I am going to solve it. Formula will be effective memory access time. Effective memory access time, that will be equal to H1 multiply T1 plus 1 bracket start 1 minus H1 bracket close multiply H2 multiply T2, then plus 1 minus H1 multiply 1 minus H2, then multiply H3 and then multiply T3. H1 is 0.8, T1 is 20 nanoseconds, H1 1 minus 0.8 multiply 0.7 H2, T2 is 100 nanoseconds, 1 minus H1 is 0.8 multiply H1 minus 0.7, then multiply H3, we will take 1 because last memory level will be taken 1 and T3 is given 10,000 nanoseconds. When we multiply both, that is 128 the 160, 28 the 160 and point after one digit left, plus 0.2 multiply 0.7 multiply 100, that is 2 sevens are 14 and 0 cut, plus 0.2 multiply 0.3 multiply 1 multiply 10,000. It will be 16 plus 14 plus 2 3 is the 6, 60,000 and 2 digits left decimal, that is 600, that will be 630 nanosecond. This is the effective memory access time through the simultaneous memory access organization. Now second, access memory access time with hierarchical method. In this method we will use formula H1 multiply T1 plus 1 minus H1 bracket close multiply H2 multiply T1 plus T2, then plus 1 minus H1 multiply 1 minus H2 multiply H3 multiply T1 plus T2 plus T3. 0.8 multiply T1 is given 20 plus 1 minus 0.8 multiply 0.7 multiply 0 T1 is given 20 plus T2 is given 100. 1 minus 0.8 multiply 1 minus 0.7 multiply 1 multiply 20 plus 100 plus 10,000. Now solve it. That is 16 plus 0.2 multiply 0.7 multiply 120 plus 0.2 multiply 0.3 multiply 1 multiply 10,120. Now 16 plus 2 sevens are 14. 120 multiply 14. 0, 42 is the 28. 14 was the 14 plus 2, 16. Now take the decimal after 2 digits left. 16.80 plus 2 3 is the 6. 10,120 multiply 6. 6 to the 12. 6 1 the 6 plus 1 7 0 6. And digit will be after 2 digits left. That is equal to 607.20. 607.20 plus 16.80 plus 16. 0 0 0 1 carry 8 6 14 6 20 2 1 3 3 1 4 640 nanoseconds is the answer of hierarchy. Now today's lecture is finished. Thank you for watching this video. If you like this video, please like and share my channel, and click on bell icon button so that you can get notifications for next coming videos, which are most important for your competitive exams, for your college exams. Thank you.